Good day, everyone. My name is Alec Tolentino,
And I am Roland Martinez.
and today we will be discussing about Activity 6, which is Frequency Shift Keying or FSK. So, what is Frequency Shift Keying or FSK? It is a method of transmitting digital signals, and it is a digital counterpart of frequency modulation or FM. It is also defined as the changing or improving the frequency characteristics of an input binary signal according to the carrier signal. Amplitude variation is one of the major drawbacks in ASK. So due to this, ASK modulation technique used in a few applications only, and its spectrum power efficiency is also low, which leads to wastage of power. So to overcome these drawbacks, frequency shift keying is preferred. So FSK is also known as binary frequency shift keying or BFSK. The below frequency shift keying theory describes what happening in the frequency shift keying modulation. So in FSK, there are two binary states, which are the logic 0 for low and 1 for high. And each of these are represented by an analog waveform. So in these figures, um, we can see the two binary states for the digital state, which is the 0 and 1. And they are represented by an analog waveform. So the logic 0 is represented by a wave at a specific frequency, and logic 1 is represented by a wave at a different frequency. So a modem converts the binary data from a computer to FSK for transmission over telephone lines, cables, optical fiber, or wireless media. The modem also converts incoming FSK signals to digital low and high states, which the computer can understand. Moving on to the datasheets and activity results. So for the procedures for this activity, for the first part is we need to first create a new Simulink model of an FSK modulator as shown in the figure on the right side. Then the second step is we will show all the block names. Then the third step, we need to change the block names of the sine wave blocks to their new names as shown in the figure, which are the high frequency on the top and the low frequency on the bottom. Then after setting the given parameters for the blocks, we will set the stop time to 1 second and run the simulation. And the output results will be discussed later on the following slides. For the second part of the experiment, the first step for the second part is we will insert a multiplexer MUX between the switch output and scope. Then we will connect the inputs of the MUX as shown in the figure. So the second step is we will describe the purpose of adding the multiplexer to a scope. And the last step is we will run the simulations. And again, the output for the simulations will be discussed on the following slides. Uh, Next, we will display the time lapse of ourselves in creating the Simulink models in MATLAB.
Hello everyone, my name is Roland Martinez and this is a video demonstration of the Activity 6 entitled Frequency Shift Keying in Digital Communications Laboratory or ECE122L Section P02. So in this video demonstration, I will show you the simulation of the block diagram for the FSK or Frequency Shift Keying in MATLAB Simulink. So this activity will be consisting of two parts. For the first part is the frequency shift keying output, and the other part is the observation of the frequency shift keying together with the output of the pulse generator. So let's get right into it. So now we can simulate our block diagram using the Control T or clicking the run button for stop time of 1 second. So after that, we need to click on the scope so that we can see the output signal or the FSK output signal. So you can observe here that the period of the sample is for 1 second, and you can zoom in so that you can differentiate the first 0.2 seconds of this sample. So again, in this output of the FSK, we observe that the frequency from 0 to 0.1 is higher than the frequency from 0.1 seconds to 0.2 seconds. So by counting the cycles of sinusoidal wave, we can see that the first set of cycle or of sinusoidal wave is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is for the high frequency, and for the low frequency 1, 2, 3, 4, 5 cycles. So the FSK has an output of combination of the high frequency and low frequency. So in the next block diagram, we can differentiate or observe the reason why the output is a frequency shifting or shift keying for this part 1. So again, we need to edit our block diagram by adding a multiplexer on the output part. So now our block diagram is done, and we can simulate it again so that we can observe the output or the FSK output with respect to the pulse generator. So clicking again the scope. Now we zoom in again to the first 0.2 seconds of this output signal. Now we can determine that the pulse generator or the pulse output is on blue color line, and for the FSK signal output is on yellow line. So here we can see that the high frequency is at on state of the pulse generator or pulse signal, and for the low frequency, the output signal is at low frequency with zero amplitude for the pulse generator or off state of the pulse signal. So this cycle is repeating for the whole 1 second sample. So we zoom in. So here we can observe that there is a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bits per second for the pulse generator, and the repetition of the FSK output signal for high frequency and low frequency is 5 sets of repetition. And that concludes our simulation for the FSK block diagram.
Good day everyone, my name is Alec of Tolentino, and I will be discussing about activity 6, which is about frequency shift keying. So the objectives for this activity is to be able to create a block diagram that can generate FSK signal on MATLAB Simulink, to be able to modify the parameters of each block of the FSK generator, and to be able to show the plots of the outputs for each block of the FSK generator. So modulation is the process of varying one or more of the properties such as amplitude, frequency, and phase angle of a sinusoidal carrier signal. When the modulating signal is a digital signal, the process is called digital modulation. Frequency shift keying, or FSK, is one of the digital modulation techniques wherein the frequency of the carrier is varied. The frequencies represent either a 1 or a 0. Frequency shift keying is the digital counterpart of frequency modulation, or FM. So this is the diagram of the FSK. Proceeding on, moving on to the procedure, which is for part 1, the simulate modeling of frequency shift keying. So the first step is to create a new Simulink model of an FSK modulator as shown below. So now I will be creating the Simulink model for the FSK modulator in MATLAB Simulink. So this is my demonstration for uh, activity 6. As we can see for the first one, the Simulink model without the multiplexer. This is the signal, that the output signal, and when we added the multiplexer, this is the output signal. The difference is that when we added the multiplexer, a square wave can be seen in the output signal. And that is all for my demonstration. Thank you.
So proceeding with the activity results, first we have to create the block diagram for the FSK modulator circuit or the system in the MATLAB Simulink. And for the input, we use the sine waves as the inputs for high frequency and low frequency. And another input is a pulse generator for the trigger of the input of the switch, where the high frequency and low frequency is the carrier signal, and the pulse generator will be the modulating signal or the intelligence signal for the FSK signal. And the switch block will create the switching between the high frequency and low frequency with respect to the pulse generated signal, and the output will be observed using the scope block. You can see on the screen the output signal or the FSK signal, and the measured switching frequency is 10 Hz, where the transition between the mark symbol or high frequency to space symbol or low frequency is observed. So we can see on the plot that the high frequency is at 0 seconds to 0.1 seconds, and from 0.1 to 0.2 seconds the frequency is low, and the frequency from 0 to 0.1 seconds is 100 Hz, while from 0.1 to 0.2 seconds is 50 Hz. The number of cycles for the high frequency is 10 cycles for 0.1 seconds, and the number of cycles for low frequency is 5 cycles for 0.1 seconds. Then there are 5 sets of cycles for the whole period of simulation for 1 second, and the 5 sets are alternating high frequency and low frequency. And there is no amplitude variation of the output signal or the FSK, since the only varied here is the frequency of the carrier signal. And we also observed that only 2 shifting frequencies, since there are only 2 different frequency carrier inputs, and this is called the BFSK or binary frequency shift keying. For the next part, we added the MUX block or the multiplexer for between the switch and the scope, where we also add the additional input using the pulse generator output or the pulse signal to the MUX, and the output will be observed using the scope. These 2 outputs will determine the relationship between the FSK and the pulse signal. So you can see in the plot that the output FSK signal is in blue sinusoidal waveform, while the pulse signal is in orange colored pulse or square wave signal. So here the relationship of the pulse signal is that it acts as the digital input, where the carrier frequencies is varied as mark and space symbols. So for the mark, it has a high frequency or at 1 or on state of the pulse signal, and the frequency for the off state or the space symbol is low frequency and the amplitude is 0. Again, at mark symbol or level 1 or at level 1's higher frequency is observed. Then at space symbol or at level 0's lower frequency is observed. Then the bit rate of the pulse signal is equal to the baud rate of the carrier signal. So in conclusion, the FSK or the frequency shift keying transmit digital information that is ones and zeros by switching a carrier signal between discrete frequencies. Then FSK is the process of shifting or modulating an analog carrier frequency at a digital rate. Then FSK closely resembles standard FM frequency modulation. With FSK, the modulating signal is not a sinusoidal signal but a series of DC pulses that vary between two discrete voltage levels. And by contrasting with analog FM modulation, where the carrier is continuously varied based on an analog input signal. And the FSK modulation is often broken down into two categories, and we have the binary FSK or the BPSK, where two discrete frequencies are used as input frequencies or carrier signals. While for the merry FSK or MPSK, we have two or more than two frequencies as input signals. And in our activity, the type of the FSK is a binary FSK or 2FSK that uses two frequencies. And we use 100 Hz and 50 Hz as two frequency inputs for the FSK modulation. And the mark symbol corresponds to logical 1 and is higher of the two frequencies, while the space symbol corresponds to logical 0 and is lower of the two frequencies. And in BPSK, the bit rate is equal to the baud rate. At the time domain of the FSK, carrier amplitude does not change and the frequency is only varied. And the frequency deviation is the distance between the carriers and the nominal center frequency. And that concludes our presentation. Thank you.